Welcome to the Stormsurf video surf forecast for the week starting Sunday, December 21st. Looking at significant wave heights for the North Pacific Ocean, we see an area of 22 to 24 foot seas in the western Gulf of Alaska. This from a gale that was pushing off Japan, working its way to the dateline, with seas previously at 37 feet, now starting to fade in the western Gulf. Swell is poised to hit Hawaii and bound for the U.S. West Coast, but not of extreme size, certainly for the U.S. West Coast, but pretty solid size for Hawaii. Otherwise, a small gale is trying to develop over the Kuril Islands and Kamchatka Peninsula, but not a whole lot is expected from this. Currently, it appears that the swell pattern and storm pattern for the North Pacific Ocean is taking a little bit of a hiatus. First up, let's take a look at jet stream level winds. These winds help support the formation of storms, and when they do form, helps direct their paths. Currently, we have a pretty healthy jet stream flow. That is, winds pushing 180 knots off Japan, a little bit of a trough here developing in the western Gulf. Actually, this is a trough that was feeding a previous low in the western Pacific, and then a ridge, that is, jet stream winds pushing a little to the north into California, into Oregon. This sets up high pressure down at the surface, and that would mean a drier pattern for California. The trough here sets up a counterclockwise pattern in lower levels of the atmosphere, and that supports low pressure. So all in all, pretty healthy flow. Let's put this into motion. Notice as we go out, winds build to 200 knots off Japan, ridging north, and then falling into this trough here in the western Gulf on Monday. But notice the trough quickly kind of pinches off, and then things start to dissolve from there as we go out into Tuesday and Wednesday. And next thing you know, we have kind of a muddled split jet stream pattern here by Wednesday. None of this supports gale development, but we still have a rather healthy flow coming off Japan, moving flat to the east, to the dateline. That is 170 knot winds, but no troughs, so that doesn't really support gale development. Maybe a little bit of low pressure in the upper atmosphere here off Kamchatka, but that's about it. We'll roll this out, continue to go. Winds push up to 200 knots here on Thursday, but still, this is a little bit of a trough trying to get going here, but way in the northwest Pacific. And notice just a completely split jet stream flow here in the east, part of it going to the north, part of it going to the south. Typically, you get high pressure that develops in between the split jet stream flow, and that means no swell generation potential. We continue to roll this out, and basically that same pattern continues to evolve, but notice the split point. Moves slowly from here, working its way east a little bit at a time, trying to make headway into the U.S. West Coast, but still, here it is at about 140, even 145 a week out, and not making a whole lot of headway, and no major troughs suggested. So whatever happens is going to be limited here to the northwest Pacific Ocean. The thought is the inactive phase of the MJO is in control right now, and that sort of takes away some of the energy of the jet, so doesn't give it enough momentum to push the whole way across the Pacific. Now this would be okay if we had some sort of big trough developing here, but it just isn't happening. So things at the surface are probably going to be less active than what they've been the past several weeks. So next, let's take a look at surface level pressure and surface level winds. Of notice, a 1028 millibar high pressure system right off California, another 1028 millibar high over the dateline. We haven't seen any high pressure like this in several weeks. Instead, it's been low after low, low pressure and fetch, just basically bulldozing across the Pacific and then making it into the U.S. West Coast. Now we get the break. High pressure comes in. So this sets up sort of a northerly flow here and a little bit almost like trades into Hawaii. And here's the little bit remnant low pressure that we saw on the 0 hour significant wave height chart. Just a small fetch of 35 knot winds. And then the other low we saw trying to get organized was a 968 millibar low in the near the Kuril Islands here in Kamchatka. All of it landlocked behind the Kuril Islands. Nothing really going on. Let's put it into motion. Roll this out. The West Gulf low disappears. High pressure hangs in by Monday, and the Kamchatka gale tries to organize a small fetch here. 45 knot winds, but lifting northeast. Basically high pressure here locking it down, so the low will sort of ride over the high up into the Bering Sea. Another little low here late Monday night off of Vancouver Island, but just not doing a whole lot, and pretty much just pushing into Canada. Here we go now into Tuesday. This is the area to watch. 35-knot west winds. That sort of continues into even Thursday. Then it falls apart. Another little fetch develops in this area of low pressure. And remember, the jet stream is going straight across here and then splitting over in this area. So notice, if it was split here, there's your high pressure, and here's your low pressure on the north end of the jet off of Japan. Another area, 35, 40-knot winds, but aimed all up into the Aleutians. Not a whole lot going on. Another little fetch here into Friday, but basically just like spurious little low pressure, not anything big and organized. And then a cutoff low tries to organize here north of Hawaii, but no real fetch associated with that either. Notice this is sort of the delineation mark now a week out between where the split point is and where weather over here is and lack of weather on this side. But even on this, on the west side of that split point, not a whole lot going on. Let's go take a look at the surface, at the significant wave height charts and see how these winds manifest in terms of creating seas. So first we're going to go back in time. Significant wave height charts here. Notice this area just west of the date line. This is Tuesday, a week ago, effectively. And watch this. This is the system that made the large swell that hit Northern California on Saturday. Watch it blow up just east of the date line. Nice area, 42, 43-foot seas, tracking well towards the U.S. West Coast. There you go. What was that? Almost 44-foot seas. And here, if you put in the Great Circle paths, watch this. We'll roll this back and watch it pretty much track as well as the system can right up the paths into Northern California. Then finally, it actually starts falling south, pushing in, and then it fades off. So this was as of Friday night. And then that swell hit on Saturday, producing a nice 18-foot Hawaiian. Early in the morning, it was probably in the 20 to 22-foot Hawaiian range, but there's a lot of tide swamping it at Mavericks. But good solid session, good solid swell. The first time we've seen, there's actually been a great run of swell going this winter in periods. Anyway, so here we go. Here's the next system that was queued up. We'll actually go back in time. It started on actually on Wednesday off Japan, kind of fragmented, couldn't quite get itself together. And then we got a little area, 36-foot seas on Thursday, 37-foot seas into Thursday night and Friday. The models jumped a little bit here. We had a server outage. But anyway, we got into Friday night, 36-foot seas, and then it pretty much faded on the just about 170 west on Saturday. Actually, Saturday morning, we had one little pocket of 30-foot seas. Now, relative to Hawaii, let's do it this way. We'll go back and take a look. This is good for very west-angled swell. So there's the 298, and that's the 305-degree paths. So we're talking about 300 degrees initially into Hawaii, and then as it starts working its way closer, you get a little bit more of a northerly angle, about 306, and here's 313 degrees. And then eventually this one is about the 312. So swell expected into the island starting Sunday, today, this afternoon. Initially from like the 300-degree track, very westerly, and then working only to 310 degrees. So any spot that favors a west swell will do well. The issue is there's supposed to be wind associated with this as well. Now the other side of it is Northern California. Watch this. And for that matter, Southern California. Here we go. This is, where are we? The 292-degree track, 295-degree track. And the storm pushed very well right up those Great Circle paths, but didn't make it very far. It was a good distance away from California. What is that? At the closest point, about 2,200 nautical miles on the 290-degree track. We'll put it back when it was, that's probably when it had the last of really good, decent energy there. That's 2,500 nautical miles out on the 289-degree track, and relative to Southern California, 2,800 miles on about the 295, Rupert Point Conception, maybe 293-degree path. So long distance swell, long waits, probably period given 37-foot seas, probably period in about the 18-second range, which is okay. Should make for some interesting surf during the work week and into the Christmas time frame. Anyway, clear that out. Let's go take a look at the future. So here we go. Starting now, here's the leftover fetch and leftover seas from that system currently in the Western Gulf. Still 22-foot seas. Again, and over a broad spread for Southern California, anywhere from, like, this says 284, and then you can go up to here to maybe 304. So maybe a bit of a spread. 13-second period energy, more than likely. This will be the tail end of the swell. Anyway, rolls out, things really settle down, little fragment bits of stuff going on here, but really the next low starts developing off Japan again Monday night into Tuesday. You got your first little pulse of something here relative to Hawaii. That's 329 degrees and 2,200 nautical miles away, and relative to Northern California, again, 306 and a long ways out, and just not anything, and not aimed very well either. And then this follow-on fetch here, this looks a little bit better here for by Wednesday night for Northern California. Notice the gray circle paths here. If you get anywhere north of this line, the Great Circle Path goes right over the Aleutians. So if you have energy up in here, which I think, no, it doesn't quite do it. But if you had a storm theoretically up in here, it would all go into the Aleutians. None of it would make it into Northern California. None of it would make it even into Southern California. The angle is, or the window is even larger to black it out. Now, relative to Hawaii, yes, 15, 18 degree path. But again, not aimed well at the islands, pushing more east. So not a big swell producer at all, but good for probably some small, fun-sized surf. And fragments of this are expected to go on into almost Friday, and then it all sort of peters out, and that's the end of that. So the short of it is, looks like there is swell in the water about to hit Hawaii, another one, and that energy will eventually make it into California, and then another little system up in here, good for more small swell for both locations, but nothing supersized. We're kind of going into a down phase. Let's go find out more about that down phase. First up, Southern Oscillation Index, difference in pressure between Darwin, Australia, and Tahiti. Now, going back in time, we had a pretty good run here into late November of negative numbers. Negative numbers suggest the active phase of the MJO, and the MJO, Madden-Julian Oscillation, in the active phase helps support storm development in the North Pacific in the winter. So clearly, the storms and the activity that we have been seeing the past 3 to 4 weeks are all related to what was the active phase of the MJO, but then it started falling apart around the early part of December, and there's a bit of lag between when it goes active and when things actually die in the atmosphere. Notice now there is some negative numbers starting to show. The current today's number is, or the index number is minus 15.93. The 30-day running average is minus 5.80, and the 90-day running average is minus 6.58. This is good in that there's daily numbers, but they don't mean a whole lot. It's the average over time. Minus 5 suggests roughly the at least the active phase of the MJO, and when you have 90-day numbers below 5, like minus 7, minus 8, that suggests a weak form of El Nino. If it was a really strong El Nino, this would be down around minus 15 or minus 20. Clearly, that's not the case. Let's go take a look at why the numbers are negative real quick. So real quickly, again, the Southern Oscillation Index is an index of the difference in pressure between Darwin, Australia, up here, and Tahiti. And notice, there is low pressure over Tahiti. And notice, we'll roll this out, this is current, and then going forward 48 hours, a string of low pressure systems, maybe even tropical activity, are suggested for the Tahiti area into Friday. And that continues on. You don't really see, and there's high pressure here and here, you don't see those isobars starting to build into Tahiti till almost Sunday. So that means, so the expectation, and notice again, it looks like another little patch of low pressure possibly developing behind that. So that would suggest that we're in for at least a week of negative numbers. That's a good thing. That might suggest that a westerly wind burst would develop, okay? When you have negative SOI numbers, that tends to suggest the active phase of the MJO. Another sign of the active phase of the MJO would be at least dead neutral trades in the equator here in the Kelvin wave generation area, if not westerly winds. So this will be something to look forward to, a nice little tease, but nothing guaranteed. So next we look for the presence of westerly wind anomalies, that is, wind deviations from normal. And so what we see is a little patch here of just barely easterly anomalies. That's not good. We want to see westerly anomalies. Here we see some very weak westerly anomalies, basically on the dateline. Nothing too impressive. Then here we go. Here's Hawaii here. We see neutral and easterly anomalies south of Mexico in that area. So this would be indicative of the inactive phase of the MJO. And if there were westerly anomalies here, that would be the active phase of the MJO. What we think's going on is there's an inactive phase of the MJO. It's definitely what's causing this jet stream to split and high pressure to build in the eastern Pacific, and you can see it real clearly there. It is north of wherever these deviations are. If they set up for a couple of days in a row, that's where weird things happen to the jet stream. Either the jet stream gets enhanced if it were west anomalies, or the jet stream falls apart if it was eastern anomalies. So that's kind of what we think is going on at the minute. Let's go see what's happening a week out. A week out, this model suggests pretty much neutral anomalies, but here we go. More westerly anomalies forecast on the dateline. Not particularly strong, but a little bit there. And then we go looking into the East Pacific. And again, notice here's those easterly anomalies, but they're working their way to the east. So the suspicion here is that some sort of a weak active phase of the MJO might be trying to make its way into the West Pacific, and the inactive phase is going to slowly work its way east. These east anomalies, though, would typically support high pressure and at the surface, especially like off California, and that would probably mean an end to the rain that has been so prevalent the past 3+ weeks. Next, we take a look at outgoing long-wave radiation forecasts. This is the statistic model. The oranges and yellows suggest the inactive phase of the MJO, easterly anomalies, and high pressure. The blues suggest the active phase of the MJO, westerly anomalies, and more precipitation, meaning less sun reflectivity off the ocean surface. So this model suggests the inactive phase, just as we suspect, where the easterly winds are south of Hawaii, working its way slowly east and fading over the next 15 days, with the active phase of the MJO trying to make headway into the West Pacific. The dynamic model paints a little bit different picture, with the inactive phase basically still easing its way east, but maybe building a little bit and not making as much headway, and therefore the active phase of the MJO can't make as much headway into the West Pacific. So the net of it is, over the next 2 weeks, we suspect probably not a whole lot of a change. Probably more of this split jet stream pattern in the East Pacific, and things trying to organize off Japan and off the Kuril Islands, but just not able to make any headway because high pressure in the East Pacific will be blocking it. That also suggests no rain and no snow in the Sierra for 2 to maybe 3 weeks. This is pretty typical MJO pattern. 3 weeks of the inactive phase followed by 3 weeks of the active phase, and back and forth, and each of these continue to work their way to the east. Both of these pair the whole way around the planet, and then it just starts over and over again. The longer 40-day upper level model, so the greens are the active phase, the MJO. The yellows are the inactive phase. The greens, in this case, are areas supportive of precipitation, which one can interpret as the active phase of the MJO. And it shows pretty much a very weak pattern. If this is the inactive phase here, and it's slowly easing its way east into about the middle of January, and here's the active phase, and it's slowly working its way east through, and makes it to about maybe mid-January and then falls apart. Actually, no, you can pretty much draw a line through it the whole way down into about, the end of January. Then here's the next inactive phase coming in. So if one is to look at this, one would say, well, the window supportive of storm development in the dateline western Gulf of Alaska would start maybe somewhere around the 5th of January and run on out till about the end of January. And this tends to be about 5 days ahead of what actually happens down at the surface. So that's kind of the high-level outlook if one is going to believe it. Now, typically during El Nino, you see a very, very weak MJO pattern. And this is pretty much what we're seeing here. A little bit of hint one way or the other, but nothing super well defined. We'll have to see how this plays out. Next, surface level ocean temperature anomalies, deviations from normal for this time of year. And the area that we're really interested in is just the equator, just a couple of degrees either side, and really between about 120 to 170 west. This is the Nino 3.4 region. This is where you want to see warmer than normal water temperatures if you have an El Nino going on. What's really interesting in this, the most current image, is this pocket of red right here. There is a Kelvin wave. That is a pocket of warm subsurface water that is starting to erupt on the surface near the Galapagos. Trades are picking it up, easing it off towards the west. This is the first sign of that new Kelvin wave. This area has been building over the past week or two, and it's getting stronger, and it's going to continue to build a little bit more, but not get really super strong. If this was a major El Nino, you would see pure red in a triangle going just like this here. We're nowhere close to that. This is more indicative of what they call a Modoki El Nino, an El Nino sort of, but not really. You got like maybe half to 1 degree anomalies averaging here in the Nino 3.4 region, and the atmosphere and everything sort of seems to support that. Anyway, this is still good, way better than having colder than normal water temperatures, which you would see. You'd see these blues like this. If we were in La Nina, it'd be cold down here, and the atmosphere would reflect that. We'd have lots of high pressure, a lot of north winds along the coast. We don't see any of that. Instead, we're seeing southerly winds, we're seeing precipitation, all typical weak El Nino signs. So here's another way to view surface water temperatures. This from buoys instead of by satellite. Rows of buoys strung across the equator, just a couple degrees, and we'll get into the details on that. But notice, here's that, remember we saw that pocket of red off of the Galapagos. Here it is, 1.5 degree, almost 2 degree anomalies right here. This is the second in a pair of Kelvin waves erupting at the surface. Trades will carry this warm water, slide it over this way. The good news that we're seeing here is warm water is again building on the dateline. It had kind of died out there for a while, and we even see what looks to be about 1.5 degree anomalies here. If another Kelvin wave were to form, there has to be a reservoir of warm water here to actually have it happen. That looks like it's developing. All we need is some westerly anomalies to start pushing to the west. That would push this warm water to depth. That would create a Kelvin wave, and then we'd have another one that would a Kelvin wave that'd show up here about 2.5 to 3 months later. So all this, notice the wind, these vectors are wind vectors, kind of neutral anomalies, a little bit of east way off here and to the far end of it, and here's your east anomalies that we saw here, you know, south of Hawaii roughly, but nothing too strong, kind of a muddled neutral pattern. But it is subsurface water temperatures that really are the what make the nose of the dog. The Kelvin wave is the tail of the dog. The warm water on the ocean surface around the Galapagos Islands is definitely the tail of the dog. Westerly wind bursts. So let's take a look at this chart and we'll talk about this. West Pacific here, East Pacific here. This is just 2 degrees north, 2 degrees south, and here's the buoys that we talked about on the equator, and they're anchors going to the bottom of the ocean, and the X's are the location of sensors on those anchor lines. And here's absolute water temperatures, which is interesting, but not nearly as interesting as the anomalies, differences from normal. Here's that Kelvin wave, so they start over here in the West Pacific. If they are created by westerly winds or westerly anomalies blowing on the ocean surface, warm water starts building in this area, falls to depth, makes itself the whole way across the Pacific Ocean under the equator, and then it starts erupting near the Galapagos Islands. And sure enough, here we go. Here's 4 degree anomalies. This is the final Kelvin wave, at least for this year, starting to erupt on the Galapagos. And we saw a warm pocket basically right about here. And this will continue for about another 3 weeks, and then things will start dying down. The question is, are more westerly anomalies coming? Is another Kelvin wave going to be developed? What we are seeing here, notice this just very faint little haze of yellow in this area. That suggests that warm water is not being transported to the east, that potentially, if we get some westerly anomalies, another Kelvin wave might develop. Here's another view of the same sort of thing. This is as of December 14th. Notice, again, here's the Kelvin wave erupting on the Galapagos, and warm water here and warm water here now starting to show up. We want to see it build in this area. That would prime the pump for yet another Kelvin wave. Now, if another Kelvin wave were to form, it being practically January, let's say, it wouldn't make its way over here till March. Typically, El Nino starts dying out by about January, February. That means it's not not gone, but the pump starts losing its prime. You don't get any more Kelvin waves working their way east. What we have been considering is the possibility of this Modoki El Nino will continue for not only this year, but maybe next year and the year beyond. So that's why we're very interested in the January through March time frame, seeing what's going on here subsurface-wise and at the surface, looking for westerly anomalies, looking for any sign that the Modoki El Nino will not die, but that it will in fact continue for months, if not the next year to come. And of course, that sets us up to look at the CFS version 2 forecast of the Nino 3.4 region. That is water temperature anomaly forecast for the next year or more. So here we go. Here's currently where we are, about 1 degree anomalies. And then what's forecast to happen is water temperatures fade a little bit, maybe down to ½ a degree in about the February time frame, but then they start creeping back up according to this model. And when we get into the July time frame, things start really taking off, and we get maybe 2 degree anomalies by into September of next year. That would put you back into what one would call a super El Nino territory, or very strong El Nino at a minimum. Now this is sort of an outlier model. It's NOAA's big main model, but models from other countries are not anywhere near as aggressive as this. Most of them are saying something bobbling around in about the ½ a degree anomaly part into next year. So we'll see what happens. But this, because of this model, this is what's really helping us, or forcing us to watch and see what goes on with great interest in the January to March time frame, and even into April over in the West Pacific in terms of westerly wind bursts and Kelvin waves and all that sort of stuff. Because the sense is Modoki El Ninos typically go for not 1 year, but 2 or 3, and then they finally culminate in a legitimate El Nino maybe 3 or 4 years out. If we get this momentum going in the atmosphere, if you have this long ongoing simmering Modoki El Nino, the jet stream stays strong, not only in the winter, but then it should pick up this summer. You should see more storm activity in the southern hemisphere for the Pacific Ocean, and then that would set you up, if things keep going, for next winter being even a better winter than the winter we're currently having in the North Pacific for 2014. So something to look forward to, a little bit of a tease. So zooming back into today, near term, what we see is swell getting ready to hit Hawaii. This is probably the last of the solid swells. That swell will also make itself into California the early part of next week. And then a much weaker pattern with a split jet stream over the East Pacific and limited activity in the far Northwest Pacific. And then beyond that, but because we're in the inactive phase of the MJO, or at least that's our suspicion, that'll hold for maybe 2 or 3 weeks. And by about the middle of January, things will start waking up again. The MJO go active, and the storm production will pick up again. And then, of course, we're very interested in looking for westerly wind bursts and more Kelvin wave development on the equatorial West Pacific, and see if that continues to feed our Modoki El Nino. So all in all, a pretty good pattern, a pretty good setup. Maybe not so great for the next 2 to 3 weeks out, but after that things should get going and rolling again. So that will be our Christmas present: more surf and more snow, hopefully long term. So for now, go surfing, go have fun. We'll do this again next week, same time, same channel, and have a great holiday. Merry Christmas, Happy New Year. We'll do this forecast maybe next Sunday, maybe not, depending on how things are going, how much time we have. But you know, we need a little downtime too. So go enjoy your time with your family and friends, and we'll get at it strong again next year. Thank you.